Everything is made up of something. Every small thing is made from something even smaller and smaller and smaller. And here we go, we have an atom. Atoms are made up of protons, neutrons, and electrons. Protons and neutrons are further made up of quarks. We know that quarks and electrons are the building blocks of all kinds of matter. Wait, are they? Let's find out by studying the quantum field theory. Particles are just localized vibrations in the field. A field is a region in space in which every point is affected by force and has a particular value which varies over time. It seems like a fluid extending throughout a large region of space so that it influences everything in it. Now consider an array of balls on a spring that are coupled with each other. If you disturb this field by tapping on a particular ball, a wave will propagate across it. These waves are actually the particles of the field. Now this swaying field is continuous, but the particles created have discrete form of energy. So that means that an electron is basically a disturbance in an electron field. This disturbance gets tied up into a quanta or a packet of energy. This idea suggests that there are no particles in this world. There are only fields whose disturbances gives rise to particles. If one particle emits another particle, that means that one field has caused a disturbance in another field by interacting with it. Although we can't visualize field, consider the beautiful pattern around a magnet that has iron fillings around it. Also think that if a gamma ray photon passes through the vicinity of a nucleus, how does it create an electron and positron? In order to create a particle in space, a discrete amount of energy is required. The mass of the particle, the greater the energy is required. Now consider a box which is emptied by taking out every particle from it. In this vacuum, whose energy is of ground state, called zero-point energy state, the vacuums still have fluctuations due to its wave-like nature. They are actually the simplest and one of the most complicated thing in the universe. The standard model tells us that there are 6 quark fields, 6 lepton field, the gluon field, 2 weak boson, 1 electromagnetic boson, and the Higgs boson field. There are total 17 fields which interact with each other through 4 different forces. Gravitational and electromagnetism, which are widely known, the strong nuclear force which holds quarks together inside protons and neutrons, the weak nuclear force which is responsible for the radioactive decay of atoms. Although the QFT is one of the most successful theories that combines quantum mechanics and relativity, there are still horizons that need to be explored. For example, the difference between quarks and leptons which are not affected by the strong force. To dig up more, the Higgs boson field which is responsible for matter and the universe. Well, the maths behind it is pretty much intimidating, but even if we solve a small part of this equation, we can unlock a myriad of secrets. Well, the question is how and when will this equation be solved? So, are you gonna wait for that breakthrough or be the one behind that breakthrough?